Good morning and welcome to our last lesson in our unit on polynomials. And this is going to cover the remainder theorem and a couple of other topics. It's actually in the notes. It is only about half a page worth of notes. I'm going to expand on that a little bit because I am stretching what was one 90-minute lesson into about 3 25-minute lessons with some practice rolled in. And this is just to expand on the division that we've been working on for the last few classes. And the question I have up there is, other than a straightforward division problem, how else might questions be asked? Because a lot of times you might be given just a division problem, like take this polynomial and divide it by this polynomial. Other times it's going to be a division problem, but it's going to be asked a different way. It's not going to be given to you as a division problem. So one of the ways, and we're going to go down a little bit of a rabbit trail here, but I want to connect what we're about to do to hopefully something you already know. If I were to ask you, is 43 a factor of 2,462? Okay, none of us know our 43's tables, so I'm going to pause the video at this point in class, and I'm going to see what you guys come up with. And of course, face to face, I'll solicit some responses from the class. But how would you answer that question? What would you do? Is 43 a factor? It's yes or no. But how do you know? So I want a yes or no. Yes, it's a factor, or no, it's not. And then I want you to tell me how you know that it is or is not a factor. Okay, of course, when I'm recording this, I don't know exactly what transpired in class, but the answer to this question is no. And typically, when I ask students to explain how they know, I'll get something like this, okay? I will put this in quotes because this is a student speaking. I divided it and got a decimal. Okay, and so the way you would answer this question is dividing it. So even though this is not a division problem, somebody did not say take 2,462 and divide it by 43, the way the question is asked, how you're going to come up with a yes or no, is you're going to divide it. And what's important is you got a decimal. In other words, I'm going to use a different color here. There was a remainder. Okay, it did not divide evenly. And that's really what you're looking for when you're answering the question, is this a factor? You're looking to see, did it divide evenly, or did I get a remainder of 0, or did I have something left over when I divided it? Now, the same concept still works with polynomials, which is why I wanted to back up, because this is a concept that I hope you already know if you were dealing with straight numbers. But math is consistent. I know I keep coming back to that. What works for numbers is going to work for polynomials also. So consider this question here. Is x plus 2 a factor of x to the 4th minus 5x squared plus 4x plus 12, which is a problem from last class. It was one of the practice problems. Oh, I should put a question mark out here. There's a question mark. Okay, and you would answer it the same way. So if I asked you, is 43 a factor of 2,462, and you take this number and you divide it by the potential factor, you will do the exact same thing here. So you're going to take the polynomial here, your dividend, yep. And I don't know what I'm writing. I just got distracted there. -5, 4, and 12. And just a reminder that this polynomial goes from x to the 4th down to x squared, and you're skipping over the x to the 3rd, and you have to hold that position with the 0 there. And then you're going to flip the sign on this, because this is, you use the 0 or the root, not the factor, okay? 0, not the factor. And then we go through drop mama. So drop the 1. Negative 2 times 1 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. Negative 5 plus 4 is negative 1. Oh, okay. Negative 2 times negative 1 is positive 2. 4 plus 2 is 6. And negative 2 times 6 is negative 12. And then 12 plus negative 12 is 0. Now remember what we're looking for. Remember, don't lose sight of the question. So if this was a straight division problem, you would need to give me the polynomial. But it's not strictly presented as a division problem. So you do need to divide to answer the question. But the question was, is x plus 2 a factor of this polynomial? Well, all we really care about was that remainder. There was nothing left over. It divided evenly. And so the answer to this question is yes. It's a yes-no question. Now, the important part, I know I'm always emphasizing this, is the why. I know it is a factor because the remainder was 0. It divided evenly. There was nothing left over when you divided. So that goes back to the, like, whether you get that decimal, whether you get something that is left over. And so you got to kind of go out and do those decimals. So that's one of the ways, like, other than a straightforward division problem, that you might be asked the question. You still need to divide. It still falls under this umbrella of, is this a factor or the division, but it's not asked straight up like a division problem. Now, in an honors class, what we would do with this is we would actually use this and we would do something called like reducing the polynomial, where we would take our what's called a quartic, which is to the fourth. We would reduce that down to a cubic, and then we would generate lists of possible factors. It's super, super tedious. You use the first number and the last number, like so the 1 and the 12. And there's a rule, which we're not going to cover in this class, where you come up with possible factors and then you check them one by one to see whether they work. And then if the answer is yes, you write it down as a factor, and one by one you eliminate the possible factors and you come up with all of the factors. And what you do is you try to get it down to a quadratic. And then once you get to the quadratic, you're able to factor it using like slide and divide or something, or one of the other methods for factoring quadratic. It's extremely long. It is extremely tedious. And you would do it in an honors class, at least to some extent. And those of you that go on to pre-cal, you will probably have to go through it. But at least for those of you that go to pre-cal, you'll have seen this method before and you'll have seen this reasoning before, even if you haven't gone through the process. And then that's something that you can cover in pre-cal. All right, so I'm going to ask another question. It's a closely related question. Is x equals negative 2 a 0 root? Okay, 0 root, the same thing, of x to the fourth minus 5x squared plus 4x plus 12. This is actually the same question because, okay, I'm going to kind of click over to a new slide here for a moment. Remember, when we had something like this, okay, you guys will remember, this is a couple classes ago, and I actually put on the screen, I said, these are the factors, and then we developed a shortcut if you were asked for the roots or the x-intercepts, okay? And we went through all this in a lesson where we said, okay, if it's an x-intercept, then the y-coordinate of the x-intercept is equal to 0, and then you take each of these factors and you set them equal to 0, and then you undo adding with subtracting, which is why you get this sign flip. And these are the roots, or the zeros, okay, or the x-intercepts, right there. Now, notice, if I say, is x plus 2 a factor of whatever, or is x equals negative 2 a 0, it's actually the same question. If x plus 2 is a factor, then x equals negative 2 is a root. And it's the same question, just one of them is being asked, couched in terms of being a factor, and the other one is couched in terms of using the vocab for roots and zeros, which is why you need to know the difference between the factors and the roots. You need to be clear on that vocabulary, and you need to be clear on how they're related to each other. So that would actually be the same question, and you would answer it the exact same way. You would set up your polynomial division. So this is the same polynomial. So I'm just going to do the 1, 0, negative 5, 4, or 12. Only this time you do not flip. And this is where students kind of have an issue, because on the factors you do flip. But if you look back to how I've expressed this, I pointed out that you put the 0, the flipped one, out here, not the factor. So we know that when x plus 2 is a factor, that negative 2 is the 0, and you're going to put the 0 on the outside. But here, you're given the 0. So you don't need to flip it because of the form that it's given. If it's given to you as a factor, you need to flip it because you need to get the 0. If it's given to you as a 0, you do not need to flip it because it's already been flipped. Okay, I'll kind of put this. It's already flipped. Okay, and then I just did this out, so I'm not going to go through that process again because it's the exact same problem that I have right there, so you can stare at it again. And you would answer the question the same way. We would say yes, because the remainder is 0. All right, so that brings us to the last topic. So we cover, other than straightforward division, how else might you be asked a division problem? So that brings us to our last topic, which is something called the remainder theorem. I'll come over here and circle that. The remainder theorem. It is actually pretty cool that this works. And when I taught a class called Analysis of Functions, I went through a proof. You can prove why this works, kind of beyond the scope of this course. So I'm just going to tell you what the remainder theorem is. I am 95% sure that this actually is on your final somewhere. So, kind of heads up on that. And the remainder theorem is this. Okay. It is an alternative, that is the word alternative. It looks like alternative, but that's alternative. It's an alternative way to evaluate functions. Now, here's what we mean. So we got throwing out like some vocab here. Evaluate. I know I've gone over this word before. Evaluate means plug in the number and simplify. Okay, that's what evaluate has always mean. It says evaluate this, you plug in the number, you simplify. A function is something like f of x. So I'm going to give you an example, and this is a way easier to demonstrate than it is to explain. And so I'm just going to demonstrate what the remainder theorem is. So example. F of x is equal to x to the third plus 4x squared minus 8x minus 6. You are being asked to find f of negative 2. So I'll let you kind of process that for a moment. Here's f of x, find f of negative 2. Now you can absolutely do this. Plug in the negative 2. Okay, and so you do negative 2 to the third power plus 4 and then negative 2, 8, negative 2. If you have a calculator, you could plug it in exactly like that because you know that function notation, f of negative 2 just means that x is negative 2, so you plug it in negative 2 everywhere, and you're going to get some number out. In fact, you're going to get an 18 out. With a calculator, it's not a big deal, except it is a lot of buttons to push. I mean, the parenthesis, negative 2, parenthesis, cubic thing, then the 3 plus, and so it takes a little while. If you don't have a pretty good calculator, it's actually pretty error prone. You've got to do each part of this separately, and Yeah, and figure that out, and I don't feel like doing it. So that's one way you can do it. You can always do it that way. There's absolutely nothing wrong with it, unless the directions say for you to use the remainder theorem. So what on earth is the remainder theorem? It's actually really great news. To do this with the remainder theorem, we are going to take this into synthetic division. We go ahead and write 1, 4, negative 8, negative 6. 1, 4, negative 8, negative 6. And you do not need to flip it. Okay, because you're plugging this number in. So this is a no flip situation. And we're going to do synthetic division. Whatever we get for the remainder out here on the right, that is what f of negative 2 is. It's actually pretty cool. So let's go ahead and drop mama. Drop the 1. Now, I am going to point out that like a lot of the problems we've done, probably because of how I've written them, the leading coefficient is a 1, but just remember the drop part, you're going to drop whatever number that is, even if it's not a 1. So please, just a quick little reminder, it might not be a 1. Mama. Negative 2 times 1 is negative 2. 4 plus negative 2 is 2. Negative 2 times 2 is negative 4. Negative 8 plus negative 4 is negative 12. Negative 12 times negative 2 is positive 24. And negative 6 plus 24 is 18. Whatever you get for that remainder, that is the value of f of negative 2. And so f of negative 2 is equal to 18. Pretty slick that works, and it's actually quite a bit faster and quite a bit less error prone than plugging it in. Now for really, really simple functions, it's easier to plug the number in. So if you had something that was just like f of x is equal to x plus 3 and you were asked for f of 4, obviously the easiest way for you to do that would be to just do 4 plus 3, so f of 4 is equal to 7, okay? That would be like the easiest way to do it. But if you have a pretty long, messy polynomial, it's probably easier to do it this way. So I have one more quick example. We are going to do, let me review. Example, there we go. Example. F of x is equal to x to the 4th plus 2x minus 7, and we are being asked to find f of 3. So you could do 3 to the 4th plus 2 times 3 minus 7. That's actually not going to be too bad because that's a much simpler function, but of course we're trying to practice with the remainder theorem. So let's go ahead and set up our synthetic division. We have 1x to the 4th. Now, notice what's missing. We go from x to the 4th all the way down to x to the 1st. So we actually have 2 missing terms there. We're missing x to the 3rd and x squared. So we're going to have 2 placeholder zeros, then the 2, then the negative 7. We do not flip the divisor. Okay? No flip. Not flipped. I should have just wrote no flip, but... And now we drop mama. Drop the 1, or whatever number is there. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. 3 times 9 is 27. 2 plus 27 is 29. Yeah, I have to think about that. 3 times 29 is 87. Negative 7 plus 87 is 80. There's my answer. F of 3 is equal to 80. I just think it's pretty cool. And it's pretty simple. Now, the trick here, or what's going to trip people up is there's a few things. One, it's usually not the synthetic division. The synthetic division has a couple of issues where people multiply when they should add and add when they should multiply, and making sign errors with the negatives. Kind of like the typical things that just go wrong. It's when do you flip and when do you not flip? So you do need to understand, like, am I dealing with a factor or am I dealing with a 0? Because you want the 0 to be out here on the left. So flip it if it's a factor. Don't flip it if it's a 0. And if it's a remainder theorem, you do not flip. So let's do a practice problem. F of x is equal to negative 2x squared plus 4x minus 8. And you are going to find f of negative 1. Now, what I'm going to suggest to you is do this with the remainder theorem, because that is the point. We're trying to practice the remainder theorem. But then to back it up, go ahead and take the negative 1 and plug it in using your calculator. You should get the same answer, because it's the two different ways of answering the same question. So I'm going to stop the lesson right here. For those watching at home for review purposes, I will go through the practice problem in the remaining time that we have. All right, let's take a look at this for if you're still here. So we do not have any missing terms here. So we have negative 2, 4, and negative 8. And then we have the negative 1 on the outside. Drop the negative 2. I was just saying, before we see so many problems with that leading coefficient is a 1 that sometimes students just start writing a 1. So, calling your attention to that. Negative 1 times negative 2 is 2. 4 plus 2 is 6. Negative 1 times 6 is negative 6. And negative 8 times negative 6 is negative 14. So f of negative 1 should be negative 14. And then what I'll do, just for fun, is we'll do this the other way. We're going to plug in the negative 1. And we should get the same answer. So evaluate just means plug it in and simplify. F of negative 1, and then we have to follow order of operations. So order of operations says you do exponents first. Negative 1 times negative 1 is positive 1. And now we can do some multiplication over here. 4 times negative 1 is negative 4. We'll bring down the minus 8. Negative 2 times 1 is negative 2. So we end up with negative 2 minus 4 minus 8. Negative 2 minus 4 is negative 6. And negative 6, it's a negative right there, minus 8 is negative 14. So we do get the same answer both times. You could just skip all of this by using a calculator. Just plug it in and the calculator will give you the negative 14. And you can also abbreviate some of these steps here, like you didn't necessarily have to write negative 2 times 1. You could have jumped from here down to here. It would have been okay. But you can see the contrast in the work, and you see the same answer. Pretty slick. So this wraps up everything in our unit on polynomials. There's more that we could cover. There's more out there that an honors class might cover. There's more out there that a pre-calculus class might cover. And there's time for you to do that. But this is a really solid introduction to what polynomials are and some of the basic things that you do with them, with the roots, the factors, the end behavior, and the graphs, and the division. And so next class will be our review day for your test.